This is episode 1 of the Introduction to Matlab, Octave, and Scilab course. This episode is going to be about basic computation and variables. In this episode, we'll learn how to form calculations on the command line in the command window, what the display statement is, basic arithmetic operations, order of operations, basics of variables, and logical expressions. For you that may have already known another computer language, this will probably seem fairly straightforward. Mostly it's just to introduce you to how Matlab or Octave or Scilab works. Again, this course is going to be shown in Octave, but it's just as relevant to Matlab and Scilab. So we'll go to Octave now. Okay, this is the Octave command window right here. There's some other windows over here. This is just basically a history of what has been done in the past. Workspace has some variables that are in memory. This is just sort of a browser into your file system. I've changed the colors, fonts, and size for the command window so it's hopefully easier to see on the computer. So we're going to start out by, this is an interpreted language, so you can do things like 1 plus 1, and it'll give you the answer 2. So the plus sign is what you think it is. The asterisk is the times sign, so if you go 2 asterisk 3 or 2 times 3, it'll give you 6. If you want to do a subtraction, it's what you think it is, 5 minus 3. Also, you can do exponentiation, which is the caret symbol. Like 2 to the third is 8. You could do something like the square root of 2 by going 2 to the 1/2, or 2 to the 0.5 will give you the same answer. And then the order of operations. Okay, so the next highest thing is parentheses. Anything inside parentheses, just like normal mathematics, is done first. So if you did 1 plus 3 times, 4, it'll do the 1 plus 3, and 4, which will be 4 times 4 is 16. So the next precedence after parentheses is exponentiation. So if you do like 1 plus 2, to the third power or something, the way it'll calculate this, it'll first do the 2 to the third and then everything else. So that's 2 to the third is 8, and then as 1 is 9. The next order of operations that is the multiplication and division. They're the same precedence, so any operation that's the same precedence goes from left to right. So if you do something like 1 plus 2 times 3 plus 4 divided by 7, squared. So how this will interpret this is first it'll do what's in the parentheses, 1 plus 2. Then it'll do anything with exponents. It'll do this 7 squared here. Then it'll do multiplications. There's only one here, so it'll do the multiplication and division, the same. So then it'll do that. And then the last precedence is addition, so it'll add them together to get the result of whatever that is. So so you may have heard this. Let me slip back to the other screen. So the order of operations, as I was showing, is you first compute anything inside parentheses, then exponentiation, then multiplication and division, then addition and subtraction. This can be remembered, you may have seen this before, PEMDAS, for parentheses, exponentiation, multiplication, division, addition, subtraction. A way to remember the order of operations. However, once you get farther in this, there are more order of operations you have to be considering, because there are other type of operators that have different precedence than any of these. So there are more rules of order of precedence that you have to, order of operations, they have to learn for most programming languages, including what Matlab or Octave or Scilab. So variables. So one of the things that makes a computing language, we can have variables. Variables are containers that hold numbers. Variables are containers that hold numbers. So in Matlab, the first character can either be a capital A through capital Z, a lowercase a to a lowercase z, or an underscore. After the first character, any combination of characters and numbers, but not some of the special characters. Also, case is important. The variable lowercase a is not the same as variable uppercase a. Variables can't have special characters in them other than underscore. Here's some examples. And the period is used for fields within a variable, which we're not going to talk about in this episode, but it's something we'll go for later. Okay. Manipulation of variables. The equal sign in Matlab or Octave or Scilab or a lot of other programming languages does not mean the same thing that it means in mathematics. What the equal sign does is it takes whatever the result of the right-hand side of the equation and set whatever the value in the variable on the left-hand side. You'll sometimes hear the term R value and L value to give that concept. For example, the statement x equals 2 takes the value 2 and puts it in the variable x. The statement 5 equals 3 times 5 plus 1 computes the value 16 and places it in the variable 5. The statement g equals g plus 1 adds 1 to the previous value of g and places that result in the variable g. Mathematically, that doesn't make sense, right? That's the same as saying 0 equal 1. But what this really means is whatever you do over here, you put it whatever's on the left-hand side. Okay, so I'm going to show you how that works now. If you say x equal 2, you get that statement, x equals 2. So now if you just type x, it'll say 2, x equals 2. Now if you don't want to say x equals 2, you can say disp x, disp is short for the display, and it'll just print 2 on the command line. That's what disp, that's what disp does in the command window. So you can say x equals 3. Notice x and x are two different variables. You can do things like y equals x times x. That lowercase x is 2, uppercase x is 3. 2 times 3 is 6, which is then y is set equal to that. And then if you do, whoops, that was an error. Let's fix that. It does 6. Now, you can also, there's a special variable called ANS, and it gives the last result of a calculation. So if you go 2 plus 2 and you say answer, it's a special variable that holds the result of a manual calculation, basically. So it's just one special variable. You don't want to have your own variable called ANS because it will conflict with what is in the programming language itself. There are some other ones you can't use, but that we'll learn that as we go. For instance, you can't have a variable name that's same as a built-in function. That doesn't work very well. The other thing you can do anything with a variable that you can do with you can do something like this and it'll compute just fine. Now, one thing that you want to do, if you don't want to see the result of a calculation, you can just put a semicolon at the end of the line. So if I repeat what I just did, put a semicolon at the end of it, won't see a thing. If I want to know the result of what I just did, I type ANS and it'll say, okay, it's 9. So if you want to do x equals x plus 1, it will not show the result. Now, if I do it again without the semicolon, it'll show the result. Okay, that's what the semicolon does. Okay, so we're going to get back to the PowerPoint. Here, I'm going to show you. I just talked about the ans variable. Yes, the semicolon is not a delimiter that makes the end of a statement. The only thing the semicolon does is suppresses output. And when you're writing scripts, and we'll get to that eventually, you don't want to show the result of every calculation in the command window. So you use the semicolon to suppress that output. That's the only thing it's used for. Okay, the next thing, the subject is logical expressions. Logical expressions are statements that are either true or false. In Matlab, true is equal to a non-zero value and false is equivalent to 0. So if you want to test the equality of two things, you use the double equal sign. So what the double equal sign does is it computes what's on the left-hand side, it computes what's on the right-hand side of the double equal sign, and if they're equal, it sets the result equal to 1, otherwise it sets the result equal to 0. So double equals 1 equals true, or 1. 1 double equals 2 is false, or 0. So if you set x equal to 2 and do nothing else, and then the statement x double equals 3 will be false. So we'll show how that works. So if you want to show that 1 equals 1, that's true. So if you say x equals 1, and x double equals 2 is false, but x double equal 1 is true. 2 plus 2 double equals 4 is true. You can do something interesting if you want to, like if you say x equals 2 and you want to do something, set a value that's equal to some value depending on what x is equal to, we could do something like this. X double equals 1 times 3 plus x double equal 2 times 5 plus x double equal 3 times 7. So what this will do is does what's in parentheses first. So it says, okay, x double equals 1 is 0. X double equals 2 is true. X double equals 3 is false, because we said x will equal to 2. So this is going to be 0 times 3, which is 0, plus 0 times 5, which is 5, or 1 times 5, which is 5, and 0 times 3, which is 7. So this should equal to 5. So that's just one of the things. You can use logical expressions in any expression at all. The next logical expression thing is the tilde. Tilde equals the operation not. So what this thing here is a truth table for the operation not, which is the tilde. So so truth table, you put your variables here in the last column, you put the operation. So here, if a is equal to 1, or true, not true is false. So is 0. If something's false, if something is not false, it's true, so it's equal to 1. And because of the way the Matlab or Scilab and Octave treat any other value as true, not any other value is false, because it's a not true is false. Okay, now we'll show how that works. So if we do not 1, you expect it to be 0. Not 2 is 0. Not 3.14 is 0. Not 0 is 1. You can also do stuff like this, not true. So when you put single quotes around something, it's a string. Well, a string is just a value. So and this is an array of 4 values. Since they're non-zero, not t is false, because that's not r is false, not u is false, and not e is false, because these are all non-zero. So not does weird things. You can do stuff like this. Not 1 equals, oops. Do stuff like not 1 equals 1, which is 1 equals 1 is true. So not 1 equals 1 is false. You can do not not 1 equals 2. Well, 1 equals 2 is false. And so not false is true. What about this? 1 equal not 2. It's false, right? Because not 2 is 0 and 1 is not equal to 0. How about 0 equal not 2? That should be 1, right? Okay. Okay, the next logical expression we'll look at are relationships between two variables. Those are like less than or equal to, greater than or equal to, not equal to. Here, that's a special combination of the tilde and the equals. It is just not equal. So what this do is shown here. So what we do is, okay, 1 not equal to 1 is false, because 1 is equal to 1. 1 not equals true is true, because 1 is not equal to true. Similarly, for less than, you can do a bunch of different cases for greater than, less than or equal, greater than equal. So we'll show how those work in Matlab next. Is 1 less than 2? Let's see. Is 1 less than 2? Sure is. Is 1 less than 1? No, it is not. Is 1 less than or equal to 1? Is 1 not equal to 2? Is 2 squared equal to less than or equal to 2 times 2? Yes, it is, because is 2 squared not equal to 2 times 2? No, it's not. So that's how that works. So you can say x equals 2, y equals 7 is, so we go y less than 7 is false. X less than y is true. X greater than y is false. X times y is less than y cubed is true. You can put anything on the left-hand side, anything on the right-hand side. It'll compute those first, and then look at the logical operation. So Obviously, it's a lower priority operation because you can actually have these things like you could do something weird like equals 1 less than, or let's say x less than 1 times 2 or something, and it'll say it's 0, right? Because this is false, so that's 0 and 0 times. So 0 times 2 is 0. Okay, we'll go back and look at some more logical operations. Okay, the next logical operation is AND. AND is a double ampersand. That is read AND. So this is the truth table. So A is true and B is true. If A and B is true, then if A is true and B is true, then A and B is true. If A is true and B is false, then A and B is false. For the only time that A and B is true if both A and B are true. The next one is OR. OR is a double vertical bar. That's just, you read that as OR. So the OR is if either of the statements on either side of the double bar is true, then it's true. So if 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and 0 or 0 is 0. So only if both expressions are false is the resulting expression false. So let's say is 1 less than 2 and 1 greater than 2? Of course not. Is 1 less than 2 and, oops, wrong, and 3 greater than 2? Of course it is. So you can do stuff like 1 or 2. So remember, non-zero is true. You can do 0 or 1. You can do, and is, so what happens if you do 1 plus 2, let's see, and 3, or 0, 1, because it does these and first and then or, and that's something we haven't talked about yet, the precedence. But if we did something like 1 plus 2 or 3 and 0, so what happened there? So what it did is, because AND has a higher precedence than OR, it does the 3 and 0 first, which is 0. So 0 and 3 is 1. So so in the order of operations, it always does ANDs first and ORs second. So if you want to do complicated ANDs and ORs, you might want to do is, you can do stuff is, I don't know, let's say x equals 3, and let's say y equals 4, and then you can have some statement like x less than y, or x and okay, not x, right? Because does the and first, x and not x, this is going to be true true and false, which is false. X is less than y is true, so true or false is true. So the answer is true. So now we'll go through the order of operations at this point that we should have at this point. The order of operations changed a little from what we started with. So parentheses and something called function calls, which we'll be talking up in a later episode, are the highest precedence. Exponentiation is next. Unary operations, like a unary minus or a not sign, a tilde, that happens after exponentiation but before multiplication and division. Then addition and subtraction. Then relations. The relationship operators have a higher, are lower precedence than addition and subtraction, but they're higher precedence than a logical and. So logical and is done after these, and at the same precedence level they're done left to right. And then lowest priority is the logical or. So this order of operations gets more and more complicated as you learn more operations in the language. It's a little bit more complicated than ordinary arithmetic. But we will go over that as we come to them, and we'll revise this with time. PEMDAS will help for most things, and then you just kind of have to remember the rest. So the next thing is to make sure that you understand these concepts. What I want you to do, working exercise is the best way to learn. Most of us learn best by doing. So I want you to take each of these expressions that are on the screen here and calculate them first by hand, and then to check your work, enter them into Matlab and see what happens, or Scilab or Octave or whatever you're using. Then we'll get on to the next one. I expect you to actually do this before you go to the next episode. It'll help you because it'll get you used to typing in on the command line and doing things in your whatever language you're using. So don't not do these. Do these. You'll hopefully learn something, and it'll make the rest of this course easier. All right, I will see you the next time.